Welcome back to the Beginner Game Programming Series. I'm Chili, and I think it's time for another tutorial. Tutorial 18 to be exact. But before we get on to that, I got something I want to show you. I've been a little busy lately. I've been working on a project of my own. This is not the project. This project is made by a board member who goes by the name of Ugly Pie, and he wrote a Sokoban clone. Let's see if I can get it here. Sokoban is it's a Japanese puzzle game where you push boxes around, and if I can find my enter key, there it is, I will show you. So this is it. You push your boxes onto the red squares, and when all the boxes are on the squares, you win. You can't see it, but it says it up here. It says level complete. Alright, there we go, level complete. Now what's interesting is that after he built this, I mean, this game is pretty cool. Nothing wrong with it, I like it. But after he built it, he said he wanted to implement some things like an automatic solver. He thought it would be too difficult. And I've actually been, these days I've been reading up on artificial intelligence just on my way home on the train or whatever. I got a nice textbook on my iPhone, and I've been boning up on that stuff. So I gave him some advice. I didn't think he'd actually go ahead and do it. It's not as difficult as you might think to write a program that can solve these, but it's still quite difficult for a beginner. But I mean, apparently Ugly Pie was a lot more skilled in programming than I gave him credit for at the beginning, because he wrote a solver for this thing, just following my simple advice. He wrote a simple solver. Let's see it here. If I restart level, then if I press enter, the solver should run. Here you go. Here's the guy working under the solver's solution. So this is the solution found by his solver. It's a little erratic. It makes some unnecessary moves. It doesn't find the optimal solution, but it does find a solution for these problems. So if I go to the next level, N, and I press enter to solve. First, you have to wait for a second because it's actually calculating the solution, and then it replays it after it's calculated it. So yeah, I gave him some simple advice just about the stuff I've been reading up on in my textbook, and it worked out fine. So I was quite impressed and interested. And I mean, I've been reading this book on artificial intelligence, and I've been thinking, I want to actually make something with this. I want to put all this skill, all this knowledge to work, and it looks like Ugly Pie has beaten me to it. But as you can see, I mean, it's still a very simple solver algorithm. So it still has a little bit, leaves a little bit to be desired. I mean, if you watch this solution here, you'll see that this bear just is going all over the place here. It's going crazy. It's on like methamphetamine or something. So there are definitely ways to improve on it, and I've thought about a few of them, and that's what I'm actually doing these days. I'm just programming up my own solver. I'll just have it so it'll plug right into this program here. And yeah, it's an interesting little exercise for me, but it's going to take a while. You see, this is actually a solution. It looks like he's just fucking around, but he will eventually solve the puzzle. It's just it's not the optimal solution. See, I could have seen where he could have like solved it there a couple of times, but crazy bear. Anyways, we'll just, yeah, he's almost got it. There you go. Good job, Mr. Bear. All right. So that's that, and just so you can see, here is my solver so far. So I've written a Sokoban solver class here, And here's an evaluator class that evaluates whether a solution or a board position is a winning board position. This one is a what do you call that? It's a flood fill algorithm. So it's important to figure out which squares can be accessed from the current player's square. And here's a cost estimator, just estimates the cost of the solution for the A-star algorithm. So I've been writing this kind of shit, and I'm doing my test here. I'm doing it in, I'll show you. Just builds. Yeah, builds. I'm writing my test in the console application here. So here's just loading the map and displaying it. And here is the map in a different format. And here it is after the accessibility search. So just searching which squares can be accessed from the square where the current player is standing. So yeah, and here's level 1 false, estimated cost 6. Just what I'm doing right now. So yeah, console applications, what I wanted to say is console applications can be very useful when you're just debugging stuff or testing out new theories, benchmarking code. It's a very important skill. And that is a nice segue into our lesson here, because again, we're continuing on with our console application and strings and input output. So just a quick plug here. If you're interested, go to the forum. You can find the Sokoban topic. And if you scroll down here, you don't download this one here. Scroll down and download this one here called Sokoback. And this is the one with the artificial intelligence. And you can look at that if you want. And you can read Ugly Pie's explanation here. It's pretty good. And yeah, that's all I wanted to say about that. So, let's get started. Let's get on it here. What am I doing here? Chili projects. Where is it? Strings. That's what we wanted. Strings.sln. Oh, by the way, this is the actual book that I'm using for artificial intelligence. It's called Artificial Intelligence: A Modern Approach. So if you're a beginner, it will probably be a little bit over your head, but after you get, if you're not a beginner, or after you get to the point where you're a little more comfortable with programming, I recommend you give it a look over if you're interested in artificial intelligence. And you should be interested, because AI is like, it's probably of all the things that game programmers do, it's probably the most difficult, and it's the skill that will make you the most valuable if you actually want to, pursue a career in this, or if you want to, I don't know, if you just want to be better than everyone else. If you want to be the best, you gotta learn how to program AI. So, what was I doing here? I think I had given you some homework, so we better get on that shit. The first thing I told you guys is we made a function put string here, and I said now you gotta make one for get string, basically for this stuff. Let me just make sure I remember this. So we start here and we get a prompt and we type in some stuff like poopies, and you type the following text: poopies. How very mature of you. Now, we got to do what? We got to, Okay. We got to make this into a function. We're going to call that function void get string. So this is going to get a string from the input buffer, and it's going to stick it in, or it's going to get a string from the console, and it's going to stick it into a buffer array. So we need a char pointer to buffer and int max length. I'm going to call it buff length. Alright, so far so good. Now we just gotta copy this code over here and make sure it works. Actually, I didn't like the way I implemented this. Because of why? Because I had to do this index minus minus shit. There was something in there that I just didn't like. C is equal to 0. Okay. So far so good. Now, buffer will be the same. Buff length goes in here. Bufflen. That's just the maximum length of characters that we can input. We don't want any buffer overruns now, do we? No, we do not. So, buffer index equal to null character. Right, that's the very last character. We make it the null. This should be buffer length -1 because, for example, if our buffer length is 100, we can't input 100 characters because then we'll have no room left for the null character. So the maximum we could input would be 99 characters, and then the last character would be the null. So index has to remain less than buffer length -1. There we go. Alright, I think I can make this loop a little cleaner if I turn it into a do loop, a post-test loop. So I do this while index is less than bufflen -1 and C is not equal to new line. So I put this one in here, and we'll initialize index up here now. Bah, there. And we'll get rid of this for loop. And we'll increment index plus plus. We'll increment index here. And if I do that, I think I can get rid of this here. The other thing I could do, actually this is better. What I'll do is before I start the loop, I will get a single character. C is equal to get char. Then I will put my while loop at the beginning. Delete that. So we won't have it will not be a do. Be a while loop, just a normal run-of-the-mill while loop. But because we have already gotten our first character, now if C is equal to N, it will just totally skip this. So we don't have to test for a new line in here. I say N, but I mean new line, of course. And if we do that, now that I've rewritten it so that char C initially gets a value from get char, I could do this, right? I could make it a for loop. For char, wait, I'll just copy and paste this here. X V. Alright. We initialize index outside of the loop here. Now we put our incrementer here. Index plus plus. And yeah, that should just about do it. We don't have to return anything here. So yeah, that looks a lot cleaner than what I had before, than this garbage. A lot cleaner. So let's gank on this one here. Alright, that looks good. Oh, almost did something stupid there. We don't need 2 incrementers, we need only 1. Alright, so we get car after we set it into the buffer, and we have an initial get car up here. That sounds really good to me. Sounds like we have a winner. Alright, so here's our get string function. Now let's test it out. So we have a buffer. Let's just put a # define buff len 128. Control C, Control V. Alright. So here we go. First thing we do, put string. I'm just going to put a string in here. Type in some text. And then we want to do get string buffer and bufflen. Remember, the name of an array without any brackets or anything is just a pointer to the first element in that array. So yeah, car buffer 128 just by itself is just a pointer to car buffer at 0. Alright, so we get a string. Now we're going to put string this string in here, which is you type the following text, and then we put string buffer, and then we put an end line on the end there. So if our getString function is not malformed, this should work as planned. So type in some text. Foobar. You type the following text. Foobar. Press any key to continue. Perfect. So now we just built another function. Our getString function. We put string and we have getString. Very useful functions. Alright. Now you might be wondering, why am I making you do all this stuff? These functions already exist. Very good functions for putting strings and getting strings. So we don't have to fart around with getting and putting individual characters onto the display. But it's a good exercise to learn a little bit more about how strings work on their internals and get a little familiarity with working with pointers. So yeah, we're gonna keep doing it this way. So in the put string function, we used the dereferencing operator and we used the increment operator, and we basically just looped. Our pointer just kind of walked through our string here, one character at a time, and fired it out onto the display. And with getString, we kept our pointer pointing to the base address of our buffer, and we used index. We used an index to access the individual elements. Just two different ways of doing the same thing. We could have used indexes in here, and we could have used incrementers in here. But just showing you two different ways to skin the same cat. Now, if I'm not mistaken, I believe our second mission was to create a function that would reverse a string. Let me just show you here. Here's some of the notes that I've been writing for, wait, hide this. I've been keeping up some notes for the program I'm writing here. But we'll forget about those. We'll use this. So the function, the thing that we want to do is we want to be able to invert a string. So if we get a string that says, I don't know, dude, we want the output to be idud. right? So there are two ways of accomplishing this. One way is, let's say we have our array, and it has and \0. This is the null character. I kind of fucked that up. Oh well. And one way is to basically switch the letters here, switch these letters in place. So this array, the letters will be shifted around, and this array will become E, D, U, D, right? The other way to do it would be to create an entirely new array and then copy each of these letters into here so that it ends up backwards, right? So that would leave the original array untouched and would give us a new one that is reversed. The other way is just to reverse in place. So I'm going to show you guys the reverse in place version because I think that would be easier. I mean more difficult. I don't know. I'm just picking one. Whatever, dude. It doesn't matter which one you use. But the implementation will be different depending on which path you decide to take. So, void invert string car pointer string. Remember, not constant car, because we're actually changing it. By the way, if this was the version where we were inverting it and putting it into a new string, we would have to take two arguments. One would be car pointer to a buffer, or pointer to inverted string, and one would be a constant car pointed to the original string. So the original string wouldn't change, so we would make it constant, and only the inverted version would have to change, because that's where we would be putting the inverted version of string into. But we're not doing it that way, so we only need one string. Alright. If I can find there you go. I found it. So how are we going to do this? Basically, what I'm thinking, just off the top of my head here, is we scan to the end of the... we got 2 pointers. And we scan to the end of the string, the array with 1 pointer. And when we're scanning, we also count how long the array is. And then once we're at the end of the array, we just swap... Actually, we don't even have to count the number of characters in the array. We can get away without doing that. Yeah. Now you're talking. Okay, I've got my plan here. Let's see if we can do this. Hopefully you guys have tried this on your own. If you haven't, well, shame on you. So, we need 2 pointers. I'm just going to declare them outside of the... I think I'm going to use a while loop this time. So, we need 2 pointers. Car pointer to... Actually, we can be sneaky and we can use the string pointer as one of our pointers. I don't think we have to... String pointer will point to the beginning of the string, but we can also increment it to point to further characters. We don't have to keep track of the beginning of the string after we've started, I don't think. No. So we're going to be sneaky and we're going to reuse that variable. So, first we get car pointer to end. And we will... what do we do? We'll say it's equal to string. So we'll start our end pointer pointing at the beginning of our string. And then we go for... And we've already initialized our end pointer. As long as the target of end, which is the character, that it points to. As long as this is not equal to backslash 0 end plus plus. And we can, if we don't have anything, we're not actually doing anything in our loop. All we're doing is looping to the end of the string. So we can just put a semicolon at the end of our for statement. The only thing we want to do is we want to just increment end until it hits the end of the string. So this now, at the end, when this for loop finishes, end will be pointing to the null terminator of our string. So, but we don't want it to point to the null terminator. We want it to point to the character before the null terminator, the final character in the string. So we do one end minus minus. We take it back one step. And now our end actually points to the end of the string. So now we can get busy. While, so let me just show you what we have here. If I can find my freaking, there it is. So we've got a string in memory, and we'll say that string has 1, 2, 3, 4, 5 letters plus the null terminator, 0. What's a good 5-letter word? Pubes. What else? So, after that first loop, end is pointing to here, and string is pointing to here. Alright? And what we're going to do is we're going to swap the thing pointed to by end and the thing pointed to by string, and then we're going to increment string so that it points here, and we're going to decrement end so that it points here. So first we swap, meaning we change the S and the P, and then we increment and decrement so that now they're pointing to U and E, and then we swap again. So now the E goes here, U goes here, and then we increment and decrement, and now they're pointing to the same character. So this is the end of the loop. So basically we keep looping, incrementing and decrementing until, or we keep looping while string is less than end. And when they are equal to, or when string is equal to end or greater than end, then we end our loop, because we've crossed the middle of the we've actually met at the middle, or we've crossed the middle of the string. So while string is less than end, one second, I'm going to turn on the lights. Alright, much better. I can see my keyboard now, because I still don't know where all these weird keys are at on my keyboard, because it's stupid. Alright, so while string is less than end, no, don't do that. I've got a glass top table so I can see through it to my keyboard, which is actually underneath the desk, but the table is so dirty right now that I can't even see through it. So turning on the lights did not help that much. Alright, so while string is less than end, we want to swap string and end. So car temp is equal to, no, bro, yes, is equal to the target of string, and then the target of string is equal to the target of end, and then the target of end is equal to temp. So we swap the characters pointed to by string and end, and then we increment string, so string plus plus, and decrement end plus plus. And then no, we don't do that. No, we don't do that. Where is it? Fucker. There it is. And then we end that. And that should be it. That should be all you need to do to swap the array, or to invert the array of characters, invert the string. So let's do a quick build here, make sure I'm not full of shit. Build solution. Works on paper. The question is, does it work in practice? So what we want is, I'm gonna get rid of all this shit. We don't need this shit. Shit, you are not needed. Type in your name, bro, and put string. Your name backwards is blah. And now we want to put string. No, wait. So we get string here. Then here we want to invert string, the buffer. And then your name backwards is, and put string buffer, and carriage return, line feed, and find my delete key. There it is. No, that was enter. There's my delete key. Whee! And now we should be ready for business. So build and go. Type in your name. My name is Chili. Okay, that was not good. I fucked it up somehow. Let's see what I did wrong. Obviously something in the invert string thing. Ah, you cocksucker. Wait. Okay. So, it's time to debug. Because debugging is the cool thing to do. So let's start... Wait. Yeah, we're in debug mode. Let's start debugging. Let's type in our name. My name is Chili. What's your problem? Unhandled exception, access violation. Can I do something, bro? Here we go. Okay, so we get an access violation, and this is somewhere in the actual C runtime library. All the crazy happy stuff that goes on behind the scenes, and it doesn't help to look at this because we don't know where this is in our program. So what we do is we go down here to call stack, and we can wait. So we have a problem here, but debugger is not going to help us out too much, unfortunately. So we're gonna have to look at this ourselves. But when we have some idea of where the problem is. Basically, we know it's gonna be in invert string. So let's put a breakpoint up here, and let's start debugging again. I'm gonna type in my name, and here we are in our function thing. I'm just gonna make this a little smaller. Okay, so first thing first, let's look at our autos. Okay, so string points to Chili. That's the contents of the array that string is pointing to. And end is right now, it's a bad pointer because we haven't initialized it yet. So let's initialize it. Now they point to the same thing. Now we're going to step through string and point to the end of it. So now, as you can see, end is now pointing to the H. So now it's hilly. And if we keep stepping, it's illy, and it's li, and it's I, and it's empty. And then we'll end, so it'll point to the last character, which is the I, the final I in Chili. So now string is pointing to the first thing, which is the C, and end is pointing to the last, which is the I. And as long as string is less than end, okay, I know what the problem was. End is supposed to go minus minus. I'm an idiot. I do this shit all the time, people. You have no idea. Okay. Problem solved. Kind of sucks though that I wasn't able to use the debugger when it crashed. Kind of went off into some crazy part of the code that is not helpful at all. Oh well. So, now this should work. Crossing fingers here. Enter your name for the 5th time. Your name backwards is Ilich. Good. Now that was the case for a name with an odd number of characters. We need an even number, because it works a little bit different when there's an even number, right? So let's try, what's your name? Foobar. And Rab Oof. Okay, good. So that is the invert string function. Not much to it, as long as you don't fuck up and get your incrementers and your decrementers mixed up. Alright, so that's all fine and good. But now let's move on to something a little more challenging. Now so far we can get text, we can get strings from the keyboard, we can output strings to the display. But a lot of our programs, they don't deal in strings, they deal in data, numbers. And if we want to put those numbers onto the display, we need to do some tricks here. So let's take a look at this here. So let's say we have the number 201, and we want to display that onto the screen. Well, first we have to convert it into a string. And that string is going to be 3 characters plus the null, so it's going to be 4 altogether. 3, 4. That's a really long null. Whatever. Alright. And you might think, oh, that's simple. You know, there's a 2, you put a 2 in here, you put a 0, you put a 1, there you go, you're done. But how do you know how to do that? First of all, let's go back to basic principles. What characters are just numbers as well, right? So we have to put numbers into this array. What numbers do we have to put in? Well, the first digit here in the 100s place is a 2. So we go and we look in our ASCII chart and we see that 2 is 50. So we have to put a 50 in here. What's 0? 48. And a 1 should be 49, right? 49. So we need to somehow convert this single number into 3 different numbers and store them in the correct order in an array. And that will give us our string. This is identical to, this is actually /0, that's a 0 at the end, null terminator, which is identical to 2, 0, 1, null terminator, right? Equivalent. So we need to find some way to turn this single number into 3 different numbers in an array. Now the trick is we have to break this number into its component digits first. So at the 1s place, at the 10s, and at the 100s. So we have to get the value of the single digits, a 1, 0, and 2. And that will enable us to convert these single digits into characters. So, how do we take a number like 201 and break it into individual digits? The way you do that is you use the modulus operator, right? If we take a number like 201 and we do a division, wait, I fucked it up. And we do a division by 10, we know that the quotient will be 20 and the remainder will be 1. All right? And the remainder, if we're dividing by 10, the remainder will always be the 1's digit. So if this was 207, the quotient would still be 20, but the remainder would be 7. Understood? And as you remember, to get the remainder, we do... what was it again? I forget what this number is called. Anyways, we do the number being divided, mod, that might be backwards, mod 10. And that will give us the ones value right here. So we want to use the mod to get the ones value in here. Alright. And once we have the ones value, let's get rid of this here. So let's say our number is 207. We do 207 mod 10 is equal to 7. So that's the first digit here is a 7. Now, here's where the interesting part comes. A 0 in ASCII is 48. Alright? Now, if we add 7 to 0, 1, 2, 3, 4, 5, 6, 7, we get 7, the digit 7. So if we add 7 to 48, 1, 2, 3, 4, 5, 6, 7, we will get the ASCII code corresponding to the digit 7. So all we got to do is get the value of a digit, and then car digit is equal to, well, in this case it would be equal to 7 plus 48. Right? 48 being the character symbol or the ASCII code for the character 0. So as long as we can get the value of a digit, we can then convert that value into an ASCII code just by adding 48. Alright, so far so good. Now, I'm just going to leave that. Now the question is, okay, so we can get the digit here, but what about this digit? What about this digit? Well, all we have to do then is once we've extracted the ones digit, we just do 207 divided by 10, and that will give us 20. And then we do 20 mod 10, and that will give us our second digit. So here's our first digit, here's our second digit. Then we go 20 divided by 10, and that's equal to 2. And then we can go 2 mod 10. We don't have to, but let's do it to be consistent. And we get 2. 702, 207, 207. So the basic flow here is we get a number n. N is equal to 207, right? First thing we do is digit value is equal to n mod 10. All right. Then digit car is equal to digit val plus 48. Right. And then we can put that into our array. And then we do n is equal to n divided by 10. So dividing n by 10 will basically shift it over to the right. So if we have 207, we divide it by 10, we get 20. We divide by 10, we get 2. Right? 1874. We mod out the 4, then we divide by 10. We mod out the 7, we divide by 10. The 8 divide by 10, the 1 divide by 10. So we're basically shifting our decimal number to the right and then we're extracting the ones digit. Shift to the right, extract the ones. And every time we extract the 1, we convert it to an ASCII code, and then we store it in our array. So that's what we're going to do. I hope that was sufficient explanation. So this will convert a number into a string, and then we can display it on the screen. So void int to string, int, we'll just call it n, car pointer to buffer, int buffer length. So here's how we're going to do it. First thing we do is we're going to make it an unsigned int. I don't know if I've explained this before, but any of these integral values, like int or char, they can be unsigned, which means they can, if they're unsigned, they don't take on negative numbers. It just makes things easier sometimes, or it gives you more space to work with. Just a quick explanation here. Normal ints, they go from -2 billion, I think, to +2 billion. But if you know that you're not going to be using negative numbers, you can make it simpler, and you can just go unsigned int. And unsigned ints, they go from 0 to +4 billion. So you give up on the negative range, but in exchange for that, you get double your range in the positive side. That's unsigned values for you. I'm making it unsigned because if we had to convert to integer and take into account the sign, it would be more complicated. Not too complicated, but it would be a little bit more complicated, and I don't really care to figure that out. All right. So let's get on it. So as long as let me think here. For as long as n is greater than 0, n is equal to n divided by 10. So here's our basic loop. We're dividing n by 10 repeatedly as long as there's still some value left in it. Now, inside the main body of the loop, we do, what do? We want to keep looping as long as n is greater than 0, and as long as we're going to need an index value. Let's make this a normal loop. Nothing fancy. Int I is equal to 0. That's our index into our character array, our string, our buffer, if you will. As long as I is less than bufflen minus 1, right? Remember, we need that one entry at the very end for the null terminator. And as long as n is greater than 0. And we'll just do I++ in here. All right. So as long as we're not at the end of our buffer and there's still some value left in n, what we want to do is we want to, into our buffer at I, we want to put n mod 10 plus 48, I think it was 48. I don't think we need brackets here, but I'm going to put them anyways. Never hurts to be safe with your order of operations. So this will convert the ones digit into a character and store that in our buffer there. And after we've converted, we want to do n equals n divided by 10. So we'll just do n, is that divide and equals 10. And that will shift our number to the right by one digit. And there we have it. And then if I can get this fucking keyboard to find... No! I swear those keys are moving around on the keyboard. They're not in the same place they were yesterday. What I want to do here. Then at the very end, we want to go buffer fucker. No, we don't want to go buffer fucker. we want to remember the last index that we were at. So int I is equal to 0. Okay, buffer at I is equal to the null character. And we're done. All right. So here is our int to string. I hope you guys attempted this before you did the tutorial, because it's a good exercise. But if you didn't, well, then you suck. But here it is. Here's how it should work. Sort of. I actually missed something here. It's not finished yet, but bonus points if you can figure out what's wrong with this function here. There might be multiple things wrong, but there's at least one thing wrong with it that will make it not work like you would hope it would. So we're converting an integer to a string. So let's get an integer. Yeah, I'll get rid of all this crap. We don't need it. Well, except for that last thing. We need that. Alright. We'll delete that, and then we'll do this. We'll say put string, here is a fine number for you. And we'll do a backslash. I said backslash dickface. And then we will, what do we do? We're going to do int to string, and we'll put it 10, we'll put 69, that's a fine number. Nothing wrong with that number. Buffer bufflen. So we'll convert this 69 into a string. Then we'll do put string buffer, and then we'll do our backslash n for a new line. So this should put our number on the screen, shouldn't it? Any predictions as to what will come out on the screen? I guarantee it won't be 69. Let's see what it is. Okay, that was bad. That's bad, okay. Why? This is not a backslash. Yeah, that just put a /0 in there, which is not good. Let's try backslash. Right, because this backslash, like I explained before, this is treated as one character. This backslash says, okay, we're going to be inserting a special character. And then the 0 says the special character is a null character. A forward slash is just a forward slash. It means nothing special. Alright, so build. We did that already. Start. Okay, now we're not as crazy. Here's a fine number for you, 96. Well, geez, why is that? Here's another fine number, 1337. Build solution. 7331. Seems kind of backwards, doesn't it? That's because it is backwards. Reason being is that through this algorithm, we are pulling out the ones digit first, and we're putting it at the front of the string. So the ones digit becomes the very first digit, which is the most important, or the largest. So for example, if our number was 1337, the first digit to come out would be the 7, then the 3, then the 3, then the 1. So it gets inverted. So there's plenty of ways that we could solve this problem. I'm going to solve it the lazy way. What is the lazy way? Well, I'm just going to go at the very end of this and I'm going to go invert string and buffer. And there we go. That'll fix the problem. There's more efficient ways of doing it instead of just inverting it after there. Like putting it in the right order to begin with. But this way will save me work. And there you go. 1337. Leet. Yeah. So now we have int to string. Now the last piece of the puzzle remains. And that is string to int. So how are we gonna solve this one? This one's probably a little easier actually. I can think of two. So let's see here. So we want to convert strings into ints. Basically, the user will input some kind of a string from the keyboard, and that string should be some numerical digits, ASCII codes in this area. And if it is, then we can convert them into an actual number. Alright, so my undo won't let me undo anymore. That sucks. That sucks, bro. I'm just gonna go old-fashioned with the eraser here. Eraser tool. Eraser's too small. Someone told me a little tip that you can use the keyboard, the brackets, to make your tool bigger and smaller. But if you're using a pen stylus and you use the eraser thing on the back, it doesn't work for that eraser thing. The brackets will make the normal pen brush go bigger and smaller, but the eraser brush will stay the same size. Interesting little tip for you. So, converting strings to integers. So let's say we have a string here. It's got some digits like a 1 and a 2 and a 4. And then it's got a null. That's not a null, that's a new line. We want a null. There we go. Now we can convert these digits into numbers by looking at the codes here. So for example, a 1 is going to be 49. But if we take 49 minus 1, no, 49 minus 48, that'll give us 1, which is the value of this digit, the actual numerical value. Similarly, if we take 50, which is the ASCII code for 2, and we subtract 48, we get 2, which is the value of this digit. So all we got to do is subtract 48 from these numbers. Now we have to be careful because we can't be 100% sure that the user is going to enter in a number. They might enter in an F or something, and then we'll just get garbage because we'll subtract 48 from whatever it is, and it won't be pretty. So what we have to do is we have to scan the string that we get, scan it, and we keep scanning until we reach either the null or we reach anything but a digit character. So as long as we have digits like 1, 9, 3, 8, that's fine. But once we hit an F here, we say, oh, that's no more numbers. So we forget about scanning. We go back one to our last digit and we start from here. And then from here, we're going to work backwards. You'll see why we work backwards. Actually, I'm going to explain why we work backwards right now because it'll just make things easier. What we do is first we take every digit. So let's say we have, I'm just going to put an input string in here. It's going to be 4 digits, 2 garbages, and a null. Alright, so our digits will be 1, 3, 9, 2, and then we'll put like something like F and a dot, null. So the first thing we do is we scan here. We scan and we count. Do we have to count? Now I'm getting mixed up. I don't think we need to count. We need to scan first. So we scan until we reach a non-digit character. And then we jump back one. And so this will have a pointer here, string, pointing to this one. And we'll have another pointer here, and we'll just call it P. I'm lazy, I don't care. We'll call this one P. So we got pointer P, we got a pointer string. So now P points to the ones digit of our number. So what do? Well, first we take this ones digit, which is a 2. What is 2? These are actually all characters, so I'm just going to put single quotes around them to make it clear. Well, a 2 is actually a 50. So we do 50 minus 48 equals number 2, which is our number here. And then we do 2 times 10 to the power 0. Or, we'll just do 2 times 1. 10 to the power of 0 is 1. So 2 times 1 is 2. Next one. Now we decrement here. So for this one, 9, what is 9? 9 is 57. So we go 57 minus 48 equals 9. Now we go 9 times 10, 90. And we add that to the 2. Next one here, 3. What is 3? 51. 51 minus 48 equals 3. Then we go 3 times 100 is equal to 300. So we add 300 to our running total here. And the last one is going to be 1 times 1,000. 1 times 1,000 is 1,000 plus. So we add up all these numbers. 1,000 plus 300 plus 90 plus 2 equals 1,392. And that's our number. N is equal to the sum of all of these. So as we loop, as we iterate and we walk through our string backwards here, we're increasing the amount that we're multiplying the digit value by. So for every iteration of our loop, we have to multiply this thing here by 10. So first time we multiply by 1, then by 10, then by 100, then by 1,000. And we add up all that shizzle and we get the nizzle for rizzle. So let's do it. So this one will be int string to int constant pointer to string Parker. All right. So let's think here. I'm gonna put on my thinking hat on. This is gonna return an unsigned int because I don't want to think about signed numbers and stuff like that. It's too much work. So we're only considering unsigned integers. No decimal numbers, no negative numbers, nothing. Okay, so first thing we got to do is we got to scan to the end of the end of the string. Luckily, we know how to do this. I'm not going to call my variable. Yeah, I'm going to call my variable end instead of p. Just because I don't want to change this. I'm lazy. I'm lazy like that. No, but we have to change this, right? Because now we're not just scanning to the end of the string. We're scanning to the end of the number part of the string. So, in that case, we want to keep scanning until we hit a non-number thing. So how do we do that? How do we determine whether a character is a number or not? Well, we can say this. As long as end is greater than or equal to the character 0 and star end is less than or equal to the digit 9, right? This one's 48 and this one's 57. So as long as end is between 48 and 57, then everything is good. We just keep looping. But once it hits something, some other digit, like an F or a dot or a null character, then we stop our loop, we go back one, and we have our end pointer. Now we have our pointer to the end. We want to start looping backwards. So for int, what am I going to do? We'll do unsigned int. Doesn't matter either way, but unsigned int pow. I'm going to do a while loop. No, I'm going to do for loop. While loop, for loop. What do I want to do? I'm going to do for loop. I changed my mind again. I do that. Unsigned int pow is equal to 1. As long as end is greater than or equal to string and minus. Yeah, we're not going to put pow in here. We could put pow in here. Nah. Put it up here. Doesn't matter where you put it. It's just personal preference. Pow is equal to 1. Okay. So here we're looping our end to the left until it goes past the beginning of the string and then we end. There. So what do we want to do? We want to convert basically we get burr. What is at end? That's the value. That's the value of the character that we're pointing to. We want to subtract 48 from that value. Then we want to do what? Then we have the digit value. Then we want to multiply that by pow. Here we go. We need another variable here. Unsigned int sum result is equal to 0. Start that off at 0. And result, we want to plus and equal. So we want to continually add this these values into result. Then when we're done that, we say that pow times and equals 10. So it keeps increasing by a factor of 10. First time it's 1, then it's 10, then it's 100, 1,000, etc. And that should be it. Once we're done here, we can just return result so we scan to the end, then for every digit we calculate its value and we scale that value by its position in the number. And we keep increasing the value of the position as we scan left until we go past the beginning of the string, and then we end. Sounds pretty damn good to me. Pretty damn good. What I want to do now? Guess I want to test it. First, let's see if it compiles. Nope, no compiling. Constant character pointer to character pointer. Right. So this has to be constant. There we go. Alright, let's test this mother out. How many times we'll put a prompt here. And then we will put get string buffer bufflen, and then we will do what? Geez. Then we're gonna do put string. No, my brain's not working. All right, we want int value int times is equal to string to int buffer, and then we go for int x equal to 0 as long as x is less than times x plus plus, put string okay exclamation mark new line blah, and that's it. So can you predict what this will do? Hopefully it won't crash, because that means that I've done something stupid, but it might crash. It's actually quite possible. So let's put a number 7 in here, and we get okay 1, 2, 3, 4, 5, 6, 7 times, right? And you can test this any way you want. You could put a number in like 3. You get 3 times. And you're thinking, there you go. I can put 0. And you get nothing. Which makes sense, right? 0 times. You can also put garbage in here, like FE3, and you get 0. Or you can mix it up. You can do, for example, 14, your mother's a whore, 14, 143. And you'll get 14 times, and it will ignore the your mother's a whore thing, which I think is pretty magnanimous or whatever. Okay, so that means that our number thing works good. Yeah, our number thing works good. That was real eloquent. One thing though, our int to string has one little error in it, one little problem. So for example, if we do int to string and we say 0, int to string 0 buffer and buff lane, and then we put string buffer, then we put string \n. Yeah, so this should put a 0 after here, but just puts nothing. It puts a blank. So if the value is 0, the string is an empty string for int to string, and that's not acceptable. So we need a special case checker in here. And what this checks is if n is equal to 0, buff length is greater than 0, greater than 1, because we need a null character. So we need a buffer of at least 2. Let's do buff lane at 0 is equal to the digit 0, and not buff length, buffer. Duh. Derp. I need to get more sleep. That's my problem. That's what I'm going to blame it on. Lack of sleep. Or maybe I just need more caffeine. Equal to \, no, I fell for that one already once. There. So if in the special case where n is 0, and we just make sure that our buffer has enough room, we just stick a 0 in there. Otherwise, we do our normal conversion routine. Now, if we do this, debug build. Hey, dick face, why didn't that work? Ah, now you're fucking pissing me off, bitch. Okay, wait a second. Okay, why did that not work? We're built, we're up to date. Int to string, yeah, if n is equal to 0, and if buffer length is greater than 1, right? Buffer at 0 is equal to the digit 0, and buffer at 1 is equal to the null character. Alright, that should pretty much frickin' work, bro. And then I fucking go ahead and do this thing anyways. Derp. Return. Alright. Yeah, because I mean, if you do this and then you let it run down here, it's just gonna overwrite the 0 with empty stuff. So what you gotta do is you gotta return at this point and skip this if you want this to work. Now it'll work. Probably. Yeah, there you go. 0, and we get the digit 0 coming out. So now we've perfected our int to string. Well, sort of perfected it. It's better than it was before. It'll get the job done. As long as you don't want negative numbers or fractional numbers or something like that. What do you expect from a single function? Jeez. Alright. We got our invert string, we got our get string, we got our put string. We're putting together quite a library here of functions, and now I just want to quickly make that thing I was talking about, the dice game thing. So let's do that quickly. Alright, I'm back. I was gone, and you didn't even notice, through the magic of television. Or at least the magic of the pause button on my recording software. I was playing tennis for 2 hours. Now I can't remember what we were doing. Let's see here. So we have already made the string, the int to string and string to int functions. And I think, yeah, we fixed that thing here. So then the last thing to do, or the almost last thing to do, is make that dice rolling game that I was talking about. Well, not really a game, but application. So let's do it. Here we go. So put string. How many dice to roll? No. Number of dice to roll. Prompt. And then we'll do a get string on the buffer bufflan, and then we'll do what? String to int. All right. Int n dice is equal to string to int buffer. There we go. And we'll do a put string. Rolling space. What should we do here? I guess we could do another int to string. Int to string. The int will be in dice. Wait a minute. I've already got a string that tells me how many dice. But the string could have like other weird things in it too. We better convert the int back into a string. So, int to string in dice, comma, buffer, bufflan. We can reuse this buffer as many times as we want. By the way, this will, okay, then we output put string buffer, that's the number that we just converted, and then put string space dice dot new line rolling n dice, and then I'll put a double n there. There. Then we're gonna need to do some random numberization here. So $! include stdlib.h and include time.h. There. Now we gotta initialize the random number generator, so srand time null. There. And now we gotta loop this mother. Int sum is equal to 0. That's the total of all of the dice, just for funsies. And for int x equals 0, because I love x. It's my favorite number. As long as x is less than n dice, x plus plus. Int roll is equal to rand mod 6 6 plus 1. Right, so a 0 to 5, and then we add 1, gives us 1 to 6. And sum plus and equals roll. Got to keep our running total. And then we gotta convert this. Oh, we'll do this down here. Okay, so we're gonna convert this mother. We do int to string roll buffer bufflen. Convert that into a string, and then we want to put string righto. Yeah, we'll put the number. Now I'm thinking here. What do I want to put? Yeah, I want to put the buffer, definitely. And then I want to put string. I guess I want to put a space between the numbers. Could use a slash, but I'll use a space. Problem is there'll be a space after the last number, but you won't be able to see it, so I guess it's okay. And that's about it, ain't it? Then we just add to the running total, and we're finished. And finally, we do put string and \n total value rolled equal to and into string sum buffer bufflen and put string buffer. And that should be it. That will allow us to roll a bunch of dice, display that roll, and sum up the rolls and display the sum total. Let's see how bad I type this in. Not too bad. Just this little annoying thing here, no problem. Let's do it. Number of dice to roll. We're gonna roll 6 dice. Rolling 6 dice. 4, 6, 2, 4, 3, 5. Total value rolled equals 24. Oh, well. Well. Now you've made me gone and do this. I just have to. I can't stand that. Roll 20 dice. Rolling 20 dice. Total value rolled 52. There you go. So, that was all of the homework done. And that is that. I don't know what to say besides we made a bunch of functions to do stuff, and then we did stuff, and stuff was good. Stuff was done, and it was good. Let me think here. Alright, so we have all these nice pretty functions that we made, and they all work perfectly, and we're never going to use them ever again. What a waste. Well, not really a waste. Now you may be asking, why aren't we going to use them? We just made them. These are good functions. Well, the reason is because the C language provides us, in the standard library, provides us with functions which do all this stuff, and they do it better than this. So, yeah. So you might ask, well, why the hell are we doing this then? And of course the answer is for the practice, because it's a good exercise in using pointers and in understanding how strings work. So the functions that we're going to use work very similar to the stuff that we've done here inside. But of course you don't know how they work, you would just use them. And I wanted to give you a more in-depth understanding of how things are working behind the scenes when you work with strings and integers and converting between the two. And now that we've done that, we can say goodbye to these functions here. We don't need them anymore. I can't bear to delete them though, so I'm just going to comment them out. Well, I'll try to comment them out. Why can't I comment them? Comment, biatch. This one? Comment selection. There we go. I clicked the wrong one. Don't do that, bro. You had to expand all that. That's not cool. Can I unexpand it now? I want to make it smaller. Outlining, hide selection. Yes. Beautiful. Okay. Yeah, so goodbye to the functions. We don't need them anymore. We're going to use other functions. We're going to use a function. I mean, let me just show you guys stuff and it will be good. This is not what I want to show you. Now, I've gone to this page before, and if you haven't gone there, then you should go here because it's good. It's called CPP reference, and this is where it's at, people. Wait a minute. Shit. I think this is the wrong page. Maybe not. What's this? Blah, I managed to move my window thing. Don't do that. Jeebus. You stay here now? I think I resized it somehow. Well, that ain't good because... Did I really resize that? What's the size on this? You can't resize when you're recording. That's impossible. Okay, it's all good. Now, what was I doing? I was showing you guys stuff. This is it. Containers, libraries, input, output. Blah, 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 blah. I don't like you. C reference. This is the one I like. We'll deal with this stuff later. Language, strings, algorithms, numerics, input, output support. This one? Maybe. Blah. This is not the... There are other pages that I don't know about. What? Weird. I did not know about this. What is this? Interesting. I've never been to this site before. But what I want to look up is, let's try printf, c++.com. This is the one that I always use. And this is the function that we are going to be using for outputting stuff to the screen. It's more complicated than your simple put string. There's a put string. It's called puts. And it works... Wait, that's f put s. Don't worry about that. That's coming next lesson. Puts. Yeah, puts constant char string. It's the same, basically the same thing as we did, and it just writes a string to the screen. So yeah, and there's also gets, which gets a string, which is what we wrote, right? Get string, gets. And there's ones for converting from ints to strings and from strings to ints in other places, and yeah. But we're not going to use those. We're going to use a more versatile function called not called fprintf. Fuck off with your f's. It's just called printf. Where is printf? Printf. There you are. Printf. This is what we're going to use. Printf takes a string, constant character pointer, constant pointer to constant character, yeah, and it also takes ellipses, which are weird, and we will get into that later. But basically, fprintf, if you want to put out a string, like let's say we got put string here. Let me just fuck this guy, fuck you guy, and you know what, fuck you guy too. I'm commenting you out. Comment. Yes, I can hide this. I want to hide that too. We'll get back to that later. Okay, so printf. You can put a string in here, like let's say hello world \n for new line. And there you go. Hello world. So it works like put S, except this F means format. And if I can fucking wait a second. I don't know why, but this IDE freezes up sometimes when I'm recording, and if I pause and then if I unpause, it stops freezing. So weird interaction between my recording software and my IDE, which should not be happening. But anyways, what was I talking about? Oh yeah, I was talking about printf. Printf, this F means format. And what we can do is we can format data into this string. Let me show you an example. Int a is equal to 1, b is equal to 2, c is equal to a plus b. Alright? And we can do something like this. %d plus plus %d is equal to %d. And now we can go in here. You look at the prototype for this thing. It's got a string as the first argument, and then it's got ... And that ... means we can put as much shit at the end as we feel like. We're going to put three things. We're going to put A, B, and C. Those are the values of A, B, and C. So it should be 1, 2, and 3. 1, 2, and 3. Try to guess what's going to happen here. There's build errors. Well, fuck you then, bro. I know what the problem is. No. I didn't declare this as an int. I just started using it. Just started using C without actually declaring it. So we get 1 plus 2 equals 3. That pisses me off. 1 second. Pisses me off because I love having a new line at the end. Or I hate not having a new line. There we go. 1 plus 2 equals 3. So, how does this work? What's going on here? Well, basically, printf, the F part, is format. And we can stick in special format codes into this string here. So if you put a %, anything after the % is a special code, and printf will interpret it as a special code. And the %d code, what that does is it looks at this list here, and for the first %d it sees, it's going to look at the first argument in the list, and it's going to convert that into a string. It's going to assume that this is an integer. It's going to convert it into a string, and then it's going to format that string into this format string. So it's going to take this value here, stringify it, and shove it in this spot here. And the same here. This one's saying we've got another decimal coming in. Another you can wait. Stop. There. You can you put D or I. Either one is fine, and that means that there's going to be an integer value going in here. It could be an int. It could be a char. It could be something else, as long as it's an integer type, and it will display a number for it. Now you can also format in floats in here. Let me show you. Float money is equal to 100 point. Put an F on the end there. Say it's a float. We could put in here like a little string, like I got %. I think it's F, but I could be mistaken. I forget sometimes. Let me just make sure. Decimal floating point, F. Okay, there you go. I got F dollar. And now we don't want ABC because they don't exist. So we want to put here money. Monet. And what do you think will happen? Make a prediction. Take a chance. I got $100.50000. Yeah, that's weird. But when you put a float, it'll put all of the decimal places in there, the whole precision. Now you can do other stuff with the format codes. For example, like you saw there was way too many zeros on that end for it to be a dollar value. Unless you're like in finance with like currency exchange, you don't need that many zeros after the decimal point. So what we can use is here's a specifier for what kind of data you want to output. So character will interpret it as an ASCII code and print out a character. D or I will print out an integer like you saw there, A, B, and C. Here we'll print things out in scientific notation. Here, floating point decimal. I don't know what this is. This will print out a integer value in octal, which is a different base. We'll format a string into our string. Unsigned integer. Hexadecimal, we can format things in hexadecimal. This will put things in a pointer address. Not very useful. Nothing printed. This argument must be pointed to sign in. Huh? Interesting. I don't really get this one. And this, if you put a % sign and then another % sign, it'll just put a % sign in there. Because obviously for printf, this % sign indicates a special code. So if you want an actual % in your output, you got to put %%. Just try it. You'll see what I mean. So what's this here then? Left justify. Right justify. Forces proceed. Used with 0 proceed different values. F. Used with blah blah blah. It forces written output to contain a decimal point even if no digits would follow. Left pads number of zeros. Minimum number of characters. Precision for integer. For EF, this number of digits to be printed after the decimal point. This is what we want. Dot number. So how does this work? Flags. No, we want precision specifier. So we want dot to F. Right? Because if you look at this, we got dot precision and then the specifier, which is F. So if we put in here dot to F, we should just get two numbers after the decimal point, which is what we want for a dollar value. And now if we print it out, I got $100.50. I got $100.50. There you go. We could put a dollar sign in front of here if we're feeling frisky. Although that's kind of redundant, right? Dollar sign, dollar. But whatever. Whatevs. And I mean here, like if we put... you fucker. Okay. If we put 50 dot or 0.50111 or something like that, and we print it out, those last 111 are ignored because we've specified that we only want 2 decimals after that. So that's just one way you can format your output here. And there's other ways too. There's a lot of options in there. So if you're interested, then you can take a look at this here and it'll tell you stuff. Yeah. But generally it's just useful for shoving numbers into a sentence or shoving strings into another string or something like that. And yeah, that is how that works. So, as a quick demonstration, let's oh yeah, there's other stuff here too. I gotta tell you how we get input from the keyboard if we don't have our get string function. Uncomment. Okay, so here we go. We call put string. We don't call put string. We call printf. There we go. And we don't call getString. We call a little thing we have called scanf. Now scanf works a lot like printf in that they take, if you look at it here, they take a format string and you go %d, meaning you want a decimal. And this one doesn't take a value, it takes a pointer to the number that will be receiving the value. So we're going to, we better do it this way. We better go int ndice. I don't think we're not going to be needing our buffer anymore. We don't need a buffer for using scanf, by the way. We go int ndice. Scanf printf, we don't need a buffer. Int ndice here, and we'll get rid of that string to int because that's not useful. And we'll go scanf %d, and we'll pass it a pointer because to ndice, and it will actually change ndice for us. It will fill ndice with the integer value that corresponds to the string that is entered into the keyboard here. So when we call scanf, we can type on the keyboard, and when we hit enter, scanf will convert that input into, well, in this case, into an integer and store it in the ndice using the pointer that we passed it. So you got to remember, when you use scanf, you use pointers, but when you use printf, you don't use pointers because you're just passing it values. Now, let's continue. So we scanf number of dice. Now we're going to say rolling however many dice. So before we had to use 4 lines and we had to use int to string, we had to use a buffer and everything in order to output this sentence, rolling n dice. This time, check it out, people. All we got to do is go rolling $d dice, and then we put in here n dice at the end. Remember, this one, no address of operator. This one's just a value. This one, address. Remember that shit. Print f, so we're printing f, and we're just going to format this n dice into this thing here. Very simple. Now we roll down here, and we're going to do what? Int to string buffer blah. That's stupid. What we're going to do is we're going to do roll is equal to blah, print f %d and a space. We need a value in here. We need ourselves a value. Put roll in there, and then we'll tally up our sum here. And this one, same deal pretty much. Total value rolled %d backslash n, and we'll put sum here. And there you go. This is the same thing with using printf. I forgot to change that one. Printf, and it makes it much simpler. Build solution. Argument, that's fine. Scanf, this function variable may be unsafe. Yeah, scanf is a little unsafe. There's a version called scanf_s, which I think probably, let's just try it out for a second, probably does maybe something else. I don't know. No, it's the same thing. It's just safer. I don't know, man. I don't know, bro. Dang old, I don't know. But I'm going to use scanf because I'm lazy. I don't want to type that extra _s. Build solution. Run. Number of dice to roll. 35. Sweet. Total value rolled 118. Rolling 35 dice. There you go. So same thing, but less typing. Easier. And as long as you can understand these format idea, although the only thing it's doing here is it's doing the same put string, or whatever it was it put string? Yeah, put string. But it checks every character, and as soon as it hits a %sign, it says, oh, we're going to do something special. And then it runs into its converting, and it looks at the first variable past it, it converts it, and then it enters it in, it puts that converted value out, and then it continues just putting characters, and then we're done. So it's a bunch of shit all rolled up into one, and it's just good times. And you can use advanced options. I'm not going to do it now, and I might not do it later, but there are advanced options for formatting, justification, and adding spaces, lining everything up nice and whatever. But just the basics of formatting data into a format string is what you need to know about printf, scanf. And that is that. Oh, scanf, you can also put, like, for example, $$D space $D and try to scan two different numbers in one line. But we almost never do that. Just don't do it. Don't do it. Just scanf one thing at a time and you'll be good. It's kind of weird if you use multiple things. I forget how it works, and just nobody does that. Nobody does that shit. So that is printf and scanf. Pretty much all you need to know for console input and output. And there's a bunch of functions in here for manipulating strings that we'll be getting into a little bit, but not into too much depth. If you go cstring, string.h, you got tons of strings here. You can copy one string into another string buffer. You can string cat, which is concatenate strings. You can add one string to the end of another string. You can compare strings to each other, see if they're identical, or if one is greater than the other, like for an alphabetical ordering. Oh, what is it? There's lots of shit in here. String length, you can find the length of a string easily with that. String col, I don't even know how that works. I don't know. I haven't used some of these. So you can use these, and we might use them, but we will not be using them too much, because when we learn C++, we will learn STL strings, which are much easier to use. They're more intuitive than C strings. So you still need to know C strings, but STL strings will allow us to use an actual string object, not just an array of characters, but an actual object which encapsulates the string and makes it easier to work with. And it makes it more difficult to shoot yourself in the foot too. But you still have to know how to use normal C strings because it comes up no matter what. So that's console input output. And next lesson, we are going to be, the next lesson will be the last lesson where we are in the console for a while. So the next lesson will also be in the console. And in that lesson, we will learn how to open files, create files, write to files, read files, molest files, and do just all sorts of crazy stuff with files. And yeah, so files. And files actually work a lot like printf because they use a function called fprintf, which is file print format. So that's why I'm teaching you printf now. It's kind of like a lead-in. It's a segue into file access. So next lesson we'll do file access, and once we know file access, we will be very close to being able to load images and use them in our games. So load image files, create images in memory, and use those images in memory to draw sprites on the screen. And you won't have to rely on giant functions which include like hundreds of put pixel calls anymore. You can do it with a simple loop then. And of course arrays of data in memory. Alright, so I've talked enough. I hope you guys have gotten a decent understanding of pointers and strings now. And if there's anything that you don't understand yet from what I've presented so far, feel free to drop by the forum and ask a question. I'm always welcome to questions that relate to the stuff I've been teaching in the videos. Questions that relate to other stuff are good too, but don't be afraid to ask anything about if you don't understand something I'm explaining in these tutorials. Just come over to the forum and ask away. Ask and you shall receive. Alright, well, I've talked enough now. So, until next time, ta-ta.
Anyway, how is your sex